Guardians of the galaxy seeking out space rocks. Out in the vastness of space, countless asteroids hurtle through the cosmos. These remnants from the early solar system, composed of rock, metal, or a combination of both, pose a potential threat to our planet. Thankfully, scientists around the globe are constantly on the lookout for these celestial wanderers. One of the primary tools in our arsenal is the telescope. Powerful observatories scan the night sky, searching for telltale signs of movement against the backdrop of distant stars. When an asteroid is detected, its brightness and trajectory are meticulously tracked. This information helps determine its size, composition, and most importantly, whether it poses any risk to Earth. But telescopes aren't our only line of defense. Radar systems play a crucial role in refining our understanding of these space rocks. By bouncing radio waves off asteroids, scientists can obtain detailed information about their shape, rotation, and surface properties. This data helps paint a clearer picture of the potential threat an asteroid might pose, allowing us to prepare more effectively. The task of finding and tracking asteroids is a continuous one. New threats emerge constantly, reminding us of the importance of vigilance and the need for ever more sophisticated detection methods. When worlds collide. Imagining the impact. The consequences of an asteroid impact depend on a multitude of factors: the size of the asteroid, its composition, the speed and angle of impact, and the location where it strikes. A small asteroid might burn up harmlessly in the atmosphere, creating a dazzling meteor shower. However, a larger one could unleash catastrophic devastation. Imagine an asteroid, several hundred meters wide, slamming into the Earth. The impact would release energy equivalent to millions of atomic bombs. A massive shockwave would radiate outwards, flattening forests, pulverizing buildings, and triggering widespread fires. Dust and debris ejected into the atmosphere would block out the sun, plunging the planet into darkness and causing global temperatures to plummet. An impact in the ocean, while seemingly less devastating, would also have dire consequences. The impact would generate monstrous tsunamis, towering walls of water capable of inundating coastal regions thousands of kilometers away. The displacement of such a massive volume of water would have far-reaching effects on ocean currents and weather patterns for years to come. The impact scenario, regardless of the specifics, underscores a crucial point. We must take the threat of asteroid impacts seriously and continue to invest in research and technologies to mitigate this existential risk. Scars of the cosmos, echoes of past impacts. Earth bears the scars of numerous asteroid impacts throughout its long history. These cosmic wounds serve as stark reminders of the destructive power of these celestial objects and the importance of understanding their potential impact on life as we know it. The most famous example, of course, is the Chicxulub impactor. This massive asteroid, estimated to have been about 10 kilometers wide, slammed into the Yucatan Peninsula in Mexico some 66 million years ago. The impact triggered a chain of catastrophic events that led to the extinction of the dinosaurs, along with an estimated 76% of all plant and animal species on Earth. Evidence of this ancient cataclysm can be found across the globe. From the massive Chicxulub crater itself, measuring over 180 kilometers in diameter, to the layer of iridium-rich sediment found in geological formations worldwide, the fingerprints of this impact are undeniable. While the Chicxulub impact serves as the most dramatic example, it is by no means an isolated incident. Scientists have identified numerous other impact craters around the world, each telling a story of a violent encounter between our planet and a celestial visitor. These scars serve as a constant reminder of the importance of vigilance and the need to develop effective strategies for planetary defense. Section 4. Shielding our planet, strategies for defense. The prospect of a major asteroid impact may seem daunting, but the good news is that we are not defenseless. Scientists and engineers around the world are actively developing and testing various strategies to deflect or disrupt potentially hazardous asteroids, turning science fiction into science fact. One promising approach is the kinetic impactor, a technique recently demonstrated by NASA's Double Asteroid Redirection Test, or DART mission. This involves crashing a spacecraft into an asteroid at high speed, altering its trajectory just enough to steer it away from Earth. While this method might seem like something out of a Hollywood blockbuster, it represents a viable and potentially highly effective means of planetary defense. Another concept under consideration is the gravity tractor. This involves using a spacecraft's gravitational pull to slowly tug an asteroid off course over a period of years or even decades. While this method requires more time and planning, it offers a more controlled and precise way to deflect a potentially hazardous object. In extreme cases, where time is of the essence, more drastic measures might be necessary. Nuclear devices, while controversial, could be used to either vaporize a smaller asteroid or to nudge a larger one off course through a carefully calculated explosion. It's important to note that these are just a few of the many mitigation strategies being explored. As our understanding of asteroids and our technological capabilities continue to advance, we can expect even more innovative and effective approaches to emerge in the future.